120 years ago, a faint beam of light began a journey that would one day change human history. It escaped the surface of a distant planet, crossed unimaginable distances of frozen emptiness, slipped through drifting clouds of cosmic dust, curved around invisible gravity wells, and finally arrived at a fragile instrument floating silently in space. Inside that ancient light was a story, not told in words, not spoken in sound, but written in chemistry. A molecule that, on Earth, is produced almost exclusively by living organisms. And in that moment, humanity realized something profound. We were no longer alone. Since the earliest days of civilization, humans have gazed upward into the night sky and asked the same haunting question: are we alone? This question shaped myths, inspired religions, fueled scientific inquiry, and drove exploration. Ancient civilizations carved constellations into stone. Sailors navigated by stars. Philosophers wondered about other worlds, and scientists built instruments powerful enough to search the heavens. For thousands of years, the universe offered only silence. Then, technology gave us new eyes. Modern telescopes were no longer limited to visible light. They learned to read invisible wavelengths, infrared, ultraviolet, radio, revealing hidden realities. Planets once thought unreachable became measurable. Atmospheres once unimaginable became detectable. Slowly, humanity began to catalogue worlds beyond our solar system. At first, they appeared as faint shadows crossing distant stars, but as instruments improved, these shadows transformed into worlds with measurable mass, temperature, and chemical composition. And then came the breakthrough. A space telescope, positioned far beyond Earth's orbit, began analyzing the atmospheres of distant planets with extraordinary precision. By studying how starlight filtered through alien skies, scientists could identify the molecules drifting through those distant atmospheres. Each molecule absorbed specific wavelengths of light, leaving behind tiny fingerprints in the data. These fingerprints told stories. Most worlds revealed simple chemistry: hydrogen, helium, carbon dioxide, methane, and water vapor. Common molecules, expected results. But one observation changed everything. Buried deep within a spectrum, scientists detected dimethyl sulfide, a fragile molecule. On Earth, dimethyl sulfide is produced almost entirely by biological activity, particularly by marine microorganisms. It plays a major role in Earth's climate, influencing cloud formation and atmospheric cycles. But it is extremely rare in non-biological environments. Its presence suggested something extraordinary: life. The scientific community responded with caution. Extraordinary claims require extraordinary evidence. Every possible source of contamination was investigated. Instrument malfunction, data processing errors, background cosmic noise, even interference from Earth itself. Again and again, the signal remained. Statistical confidence rose 90%. 95%, 99.7%. At that threshold, coincidence becomes mathematically improbable. The simplest explanation remained: life existed beyond Earth. The planet itself was unlike anything humans had imagined as habitable. It was larger than Earth, heavier, and wrapped in a thick atmosphere of hydrogen. For decades, such planets were dismissed as sterile gas worlds, but new models revealed a surprising truth. Beneath the dense hydrogen layers lay a vast global ocean. Temperatures were warm but stable. The thick atmosphere distributed heat evenly across the planet, preventing extreme differences between day and night. This world existed in perpetual twilight, no scorching sunlight, no frozen darkness, only endless dusk above a global sea. Such stability created conditions where chemistry could slowly organize into biology. On Earth, life emerged remarkably quickly after the planet cooled. This suggests that life is not a rare cosmic accident, but a natural outcome of chemistry when conditions allow. This distant ocean world may have had billions of years more than Earth to experiment. Its star, a red dwarf, burns slowly and steadily, offering trillions of years of stable energy. Time, the greatest ingredient for complexity. In Earth's oceans, deep below sunlight, life thrives around hydrothermal vents. There, chemical gradients power ecosystems without reliance on photosynthesis. These organisms draw energy directly from geochemical reactions. If life emerged on this distant world, it likely followed similar principles. Mineral-rich plumes rising from the seafloor, chemical energy flowing through dense waters, molecules assembling into primitive replicators, replicators forming networks, networks evolving into ecosystems, slowly, patiently, over unimaginable spans of time. Life in such an environment would be profoundly different from anything on Earth. No trees, no animals, no familiar forms. Instead, drifting colonies, chemical webs, biological structures adapted to crushing pressures and perpetual darkness, senses based on chemistry rather than light, communication through molecular signals instead of sound. Intelligence, if it emerged, may exist as vast cooperative networks rather than individual beings. Yet, beneath these alien forms, the same physical laws apply. Energy flows. Entropy rises. Structures resist decay. Life organizes matter against chaos. The detection of dimethyl sulfide does not merely suggest organisms, it suggests planetary-scale biology, a world breathing, an atmosphere shaped by living processes. This discovery reshapes humanity's understanding of existence. If life exists here, it may exist everywhere. Red dwarf stars account for nearly 3/4 of all stars in our galaxy. If even a fraction of their planets host life, the Milky Way may be filled with living worlds. Life may be common, perhaps inevitable. This realization forces humanity to reconsider its place in the cosmos. We are no longer a rare anomaly. We are one expression of a universal process. The universe may naturally evolve toward complexity, toward life, toward awareness. Yet, discovery also carries responsibility. If alien biospheres exist, they deserve protection. Exploration must be guided by restraint, not exploitation. Earth microbes could irreversibly contaminate fragile ecosystems. Curiosity must be balanced by humility. We must become guardians, not conquerors. Future telescopes will soon map alien climates, detect seasonal cycles, and analyze atmospheric rhythms. We may observe storms on distant oceans. We may track planetary climates across decades. We may witness the changing chemistry of living worlds. Each discovery will bring us closer to understanding life as a cosmic phenomenon. But the greatest transformation may occur within ourselves. For thousands of years, humanity believed life belonged only to Earth. That belief shaped our philosophies, religions, and sense of meaning. Now, the universe whispers that life is far greater than we imagined. That realization can be unsettling, but it can also be liberating. We are not diminished by sharing the cosmos. We are enriched, because we are part of something far greater. The story of life does not begin and end on one small world. It stretches across galaxies, across time, across stars. Somewhere beneath crimson skies and endless seas, life is unfolding its own story, unaware of us, just as we were unaware of it. Yet now, across unimaginable distances, our stories have touched through fragile molecules, through ancient light, through curiosity and wonder. The universe has spoken, and humanity has begun to listen. The realization that life may exist beyond Earth forces us to confront questions that humanity has never fully faced before. If life can arise independently on distant worlds, then life may be a fundamental property of the universe itself. Not a rare miracle, but a natural consequence of physics and chemistry. This shifts our understanding of existence. Life becomes not an exception, but an expectation. Across cosmic history, wherever energy flows and molecules gather, complexity may slowly emerge. Given enough time, chemistry organizes into biology. Biology organizes into ecosystems. Ecosystems, in rare cases, organize into intelligence. And intelligence begins to wonder, just as we have. But intelligence may not look like us. On Earth, intelligence is shaped by gravity, light, sound, and survival pressures of land and sea. But on distant ocean worlds, evolution follows different paths. Life beneath hundreds of kilometers of water may never know stars. Its universe might consist entirely of darkness, pressure, chemical gradients, and subtle thermal currents. Instead of eyes, there may be chemical sensors. Instead of sound, pressure waves. Instead of sight, fields of molecular perception. Cognition may arise through distributed networks. Vast cooperative colonies exchanging information chemically, slowly processing environmental changes, adapting across centuries rather than seconds. What we define as thought may exist on timescales far slower than human awareness. A single decision might unfold over years. A single memory might persist for millennia. In such environments, intelligence might never develop technology, never look upward, never build machines. Yet awareness may still exist. Consciousness may bloom in quiet oceans completely disconnected from stars. If so, the universe could be filled with silent minds, living, thinking, unaware of one another, each isolated by cosmic distance, yet bound by shared origins, physics, chemistry, time. This thought transforms loneliness into kinship. We are not solitary. We are siblings in a vast cosmic family, separated by light years but united by natural law. The discovery of life elsewhere also reshapes the search for extraterrestrial intelligence. For decades, humanity listened for radio signals, scanning the skies for artificial broadcasts. We imagined civilizations like our own, technological, communicative, broadcasting across space. But perhaps intelligence rarely becomes technological. Perhaps most life never builds radios. Perhaps civilizations rise and fall before their signals reach distant stars. Or perhaps intelligence takes forms beyond communication as we understand it. Civilizations may exist beneath thick atmospheres, trapped beneath oceans, isolated by chemistry and pressure. They may never develop metallurgy, never launch spacecraft, never transmit signals. Yet their civilizations may flourish in ways unimaginable to us. If intelligence exists elsewhere, it may not announce itself. It may remain hidden, silent, unknown, which means that discovering biological life may be far more common than discovering intelligent life. Life may fill the galaxy, but voices may be rare. This possibility makes humanity's own technological phase extraordinarily fragile. Our civilization has existed for mere centuries. A blink in cosmic time. Radio transmissions have traveled only about 100 light years. Our technological footprint barely extends beyond our local neighborhood. If civilizations commonly destroy themselves or simply fade before mastering interstellar communication, the galaxy could be teeming with extinct cultures. Ghosts of civilizations long gone. Worlds that once dreamed. This sobering thought reinforces the responsibility we carry. Our choices determine whether humanity becomes a brief spark or a lasting presence. If we wish to join the long story of cosmic intelligence, we must learn sustainability, cooperation, and restraint. We must avoid self-destruction. And we must approach discovery with wisdom. The search for life beyond Earth also reflects back upon our treatment of life on our own planet. If we celebrate alien ecosystems while destroying Earth's biodiversity, we reveal a tragic contradiction. The reverence we feel toward distant life must extend to nearby life. The oceans, the forests, the atmosphere. Our planet is a living world, and it remains our only home. Perhaps the discovery of life elsewhere will inspire deeper protection here. A reminder that life itself is precious, that biospheres are rare jewels in a vast cosmic desert, that every living world deserves care. Future generations may grow up knowing that Earth is not alone. Children may learn in classrooms that life thrives across the galaxy, that biology is universal, that humanity is part of a larger living system. This knowledge may reshape culture. Art may evolve. Religion may reinterpret origins. Philosophy may expand beyond Earth-centric frameworks. Human identity may shift from planetary to cosmic. We may come to see ourselves not as citizens of nations, but as citizens of Earth. And eventually, perhaps, citizens of the cosmos. But this transformation will not be instant. There will be fear. There will be resistance. There will be denial. Each revolutionary discovery in history has encountered opposition. When Earth was removed from the center of the universe, it destabilized belief systems. When evolution explained life's origins, it challenged long-held narratives. Now, the realization that life exists elsewhere confronts humanity with its deepest assumptions about uniqueness. Some will embrace this new perspective. Others will struggle. But over time, knowledge reshapes culture, and culture reshapes civilization. Technology will continue advancing. Future telescopes may detect atmospheric oxygen on distant worlds. They may observe chlorophyll-like pigments. They may measure seasonal variations caused by biological cycles. We may one day create direct images of alien oceans, cloud systems, and continents. Each pixel will represent unimaginable distances. Each color will represent alien skies, but direct contact remains uncertain. Interstellar travel remains extraordinarily difficult. Even at 1/10 the speed of light, journeys to nearby stars would take decades. At slower speeds, centuries or millennia, generational ships may one day be conceived. Robotic probes powered by lasers or fusion may reach nearby systems. But practical interstellar exploration lies far in humanity's future. For now, we remain observers. Listening, learning, wondering. The universe does not reveal its secrets easily. It whispers them slowly through faint signals and patient study, yet each whisper reshapes our understanding. The discovery of life beyond Earth is not an end point. It is the beginning of a new scientific era. Astrobiology will become one of humanity's central sciences, a discipline uniting astronomy, chemistry, biology, geology, and physics. Its goal? To understand life as a universal phenomenon, not limited to Earth, not limited to familiar chemistry, but grounded in the fundamental laws of nature. Laboratories on Earth will simulate alien atmospheres and oceans. Chemists will test alternative biochemical pathways. Physicists will model energy flows in exotic environments. Biologists will study extremophiles to understand life's adaptability. Each experiment will expand the boundaries of possibility. Each discovery will refine our expectations. Eventually, humanity may construct a true theory of life, a framework explaining how matter organizes into living systems across diverse conditions. Such a theory would rival the importance of evolution or relativity. It would unify biology with physics. Life would become a predictable outcome of certain conditions, not a mysterious accident. In that future, discovering life elsewhere may become routine. Each new detection will add another thread to a growing tapestry. A map of living worlds scattered across the galaxy, and with each new world, humanity's perspective will expand. Our planet will appear less isolated, our history less solitary, our destiny more interconnected. Yet perhaps the most profound impact of this discovery is emotional. For millennia, humans have faced the vastness of space with a sense of cosmic loneliness. The stars felt distant, cold, indifferent. Now the universe feels subtly warmer, more familiar, more alive. We know that somewhere beneath alien skies, chemistry has assembled itself into living systems. That somewhere life is growing, evolving, and adapting. This knowledge changes the emotional tone of the cosmos. The night sky is no longer just a field of burning suns. It is a vast landscape of potential life. Every star may host stories. Every planet may carry memories. Every system may shelter fragile ecosystems struggling against entropy. We are no longer gazing into emptiness. We are gazing into possibility. And perhaps one day, communication. If humanity survives long enough, if our technology matures, if our wisdom grows alongside our power, we may eventually reach out. Not to conquer, not to exploit, but to understand, to learn, to share. The first contact may not be a dramatic arrival of spacecraft. It may be a faint radio whisper, a subtle chemical modulation, a mathematical signature embedded in cosmic noise, or it may come in forms we cannot yet imagine. However it happens, it will represent the greatest moment in human history. A meeting of minds across stars, a confirmation that intelligence too is universal. But until then, we remain students of the cosmos, reading its faint messages, decoding its chemical scripts, listening to its silent music. Each discovery is a lesson in humility. We are small, but we are capable of understanding something vast, and that ability to ask, to seek, to learn may be humanity's greatest gift. We began our journey believing Earth was alone. We now stand on the threshold of a living universe, a universe where life may bloom wherever physics allows, where countless worlds may host silent oceans, drifting organisms, and hidden ecosystems, where biology weaves itself into the very fabric of cosmic evolution. The universe has revealed that life is not confined to one small world. It is a cosmic phenomenon, and humanity has only just begun to understand its place within it. As humanity stands at the edge of this revelation, we begin to understand that discovering life beyond Earth is not simply about finding organisms elsewhere. It is about discovering our place in a universe that is far older, far larger, and far more complex than we ever imagined. For thousands of years, humans looked up at the stars and saw mystery. Myths filled the darkness. Gods walked across the sky. Heroes were immortalized in constellations. The heavens were a realm beyond human reach, distant and divine. But as science advanced, that mystery slowly transformed into understanding. The stars became suns. The wandering lights became planets. The Milky Way became one galaxy among billions. And now life itself is becoming a cosmic phenomenon. We are living through a moment that future civilizations may mark as the true beginning of humanity's cosmic awareness, a moment when we stopped seeing ourselves as isolated and began to understand ourselves as participants in a living universe. This realization reshapes not only science, but identity. It asks a simple yet profound question. If life is everywhere, then who are we? Are we explorers, observers, messengers, or simply one expression of a universal pattern that unfolds wherever time and chemistry allow? Perhaps intelligence itself is the universe becoming aware of itself, matter arranging into consciousness capable of reflection. In that sense, every thinking being, human or alien, is a fragment of cosmic self-awareness. Each civilization a temporary window through which the universe observes its own existence. This idea transforms exploration into introspection. When we search for life among the stars, we are not merely searching outward, we are searching inward, trying to understand the forces that shaped us and everything that may come after. Future telescopes will push deeper into this mystery. They will analyze the atmospheres of thousands of exoplanets. They will search for oxygen, methane, water vapor, and chemical imbalances that betray biological activity. They will map planetary climates, cloud systems, and seasonal cycles. With each discovery, patterns will emerge. Certain star types will prove more fertile. Certain planetary architectures will appear repeatedly. Life's preferences will become clearer. And as our models sharpen, we will begin predicting where life should exist before we even look. At that point, the search for life becomes not speculation, but expectation. World after world will be surveyed. Some will be sterile, frozen, or scorched. Others will reveal subtle hints of biology. And a few may blaze with unmistakable signatures of thriving ecosystems. But there is a deeper question beyond detection. If life exists elsewhere, what responsibilities do we carry toward it? Human history offers cautionary lessons. Whenever technologically advanced civilizations encountered isolated ecosystems, the results were often devastating. Species were driven to extinction. Environments were reshaped. Cultures were erased. The imbalance of power proved destructive. In space, such mistakes would be irreversible. Alien biospheres may be fragile, their chemistry delicately balanced. Introducing foreign organisms could collapse entire ecosystems. Even robotic probes risk contamination. A single bacterium from Earth could outcompete alien microbes that evolved without defenses. For this reason, planetary protection protocols are becoming increasingly strict. Space agencies now sterilize spacecraft to extraordinary levels, ensuring that Earth life does not hitchhike across the solar system. Future missions to ocean worlds like Europa and Enceladus will face even greater scrutiny. As we extend our reach beyond our home system, this ethical responsibility will only grow. We must approach alien worlds not as resources, but as sanctuaries. Not as targets of conquest, but as scientific treasures. If life exists elsewhere, it deserves the same respect we wish for ourselves. This shift in mindset represents a profound moral evolution. Humanity must expand its ethical circle beyond our species, beyond our planet, to encompass life itself, wherever it may exist. Such a transformation may define our future. Civilizations that fail to develop ethical restraint may never survive long enough to explore the stars. Those that succeed may become guardians of cosmic biodiversity. Protectors of fragile worlds, stewards of living systems across interstellar distances. If humanity aspires to such a role, we must first learn to care for our own planet. Earth is a test case, a fragile biosphere balanced between chaos and stability. Our treatment of Earth will reveal whether we are capable of cosmic responsibility. If we destroy the only life we know, how can we claim readiness to encounter others? The discovery of alien life may therefore serve as a mirror, forcing humanity to confront its own contradictions. We celebrate the possibility of distant oceans while polluting our own. We dream of future worlds while destabilizing our climate. We search for life beyond Earth while extinguishing species here at unprecedented rates. These contradictions cannot persist indefinitely. Eventually, they must be resolved. Either we learn to live in harmony with our environment, or we collapse under the weight of our own excess. In this sense, the search for life beyond Earth is not separate from humanity's survival. It is deeply connected. Understanding how other planets maintain equilibrium may teach us how to preserve our own. By studying alien climates, we may better understand climate stability. By observing planetary feedback systems, we may learn how ecosystems self-regulate. By witnessing the longevity of stable worlds, we may discover principles of sustainability that can guide our civilization. The cosmos becomes our teacher, and we become its students. As technology advances, humanity's presence in space will expand. Permanent settlements may one day exist on the Moon, Mars, and the icy moons of the outer solar system. These outposts will serve as laboratories, testing humanity's ability to survive beyond Earth. Each success will build confidence. Each failure will bring humility. But beyond our solar system, distances remain immense. Interstellar travel will demand breakthroughs in propulsion, energy generation, and life support. Fusion drives, antimatter engines, laser sails, artificial intelligence navigation, self-repairing spacecraft, closed-loop ecosystems. Each of these technologies must mature before humans can realistically reach nearby stars. Even then, journeys will span generations. Human explorers may live entire lives aboard traveling worlds, never seeing their destination. Their descendants may arrive centuries later, inheriting the dreams of their ancestors. Such journeys would represent humanity's greatest commitment. A pledge across centuries, a declaration that our species intends to become interstellar. Yet, before such voyages begin, we must answer a deeper question. Should we go? If life already exists elsewhere, what right do we have to intrude? Is exploration an inherent good, or must it yield to preservation? These questions will define future space ethics. Perhaps the solution lies in restraint, observing from afar, listening without interference, learning without contamination, becoming cosmic naturalists rather than conquerors. If humanity can adopt this philosophy, then the age of exploration may become the age of guardianship. A civilization that explores not to dominate, but to understand. A civilization that values life in all its forms. In this future, telescopes become instruments of empathy. Each new world observed becomes a story to be respected. Each alien biosphere becomes a reminder of nature's boundless creativity. And each discovery deepens our reverence for existence itself. The universe, once seen as empty, now appears alive with possibility. A vast network of chemical experiments unfolding across billions of years. Some fail. Some succeed, and a precious few blossom into living worlds. We are the beneficiaries of one such success. Earth's story is ancient. 4 billion years of evolution, countless extinctions, endless adaptation, from simple molecules to complex cells, from single-celled organisms to conscious beings capable of reflection, every step shaped by chance and necessity. Yet the same story may be unfolding elsewhere. Different chemistry, different pressures, different environments, but driven by the same universal laws. In this sense, life becomes a cosmic narrative, each planet a chapter, each species a sentence, each civilization a paragraph. And humanity, at this moment, is learning to read that story. The first detection of alien life is like discovering a single word written across the stars. A small fragment of a vast manuscript. Yet that fragment changes everything. It tells us the story exists, that the universe is not a blank page, but a living text waiting to be explored. And as our tools improve, we will read further. World by world, system by system, galaxy by galaxy. Perhaps one day we will hold a complete map of life's distribution across the cosmos, a biological atlas of the universe. Such knowledge would forever transform humanity's self-image. We would no longer be a solitary species. We would be members of a galactic biosphere. Our actions would ripple across cosmic scales. Our responsibilities would expand accordingly. This realization invites humility. We are not masters of creation. We are participants within it, temporary expressions of a universal process far older than ourselves, and in that recognition lies profound meaning. We exist not in isolation, but in connection. Not as anomalies, but as inevitabilities. Not as conquerors, but as stewards. The night sky will never look the same again. Each star becomes a potential sun for living worlds. Each faint dot a possible cradle of biology. Each constellation a map of hidden ecosystems. Every glance upwards becomes a meditation on existence. And in quiet moments, beneath the vast dome of the stars, humanity may feel something new. Not fear, not insignificance, but belonging. Belonging to a universe that creates life wherever it can. Belonging to a story far larger than any single planet. Belonging to a cosmic family still mostly unknown. And so the search continues. Through cold vacuum, through faint photons, through decades of careful measurement, every telescope built, every mission launched, every equation solved, each brings us closer to understanding our place in the grand design. The journey will be long, but it will be worth it. Because in seeking life beyond Earth, we are not only discovering others, we are discovering ourselves. And as this realization settles into the collective awareness of humanity, something subtle begins to change. our perspective widens, our sense of urgency deepens, our understanding of responsibility expands beyond borders, beyond generations, beyond even our species. For the first time, we are no longer thinking only about survival. We are thinking about continuity. What does it mean for intelligence to endure? Civilizations rise and fall, empires collapse, cultures transform, languages disappear, but life itself continues, adapting, reshaping, evolving across unimaginable spans of time. To become a truly enduring civilization, humanity must learn to align itself with the rhythms of life rather than opposing them. The universe does not reward speed, it rewards stability. Stars that burn too fiercely burn out quickly. Planets that shift too violently collapse into chaos. Ecosystems that overconsume destroy themselves. Longevity emerges not from dominance, but from balance. And so the greatest challenge facing humanity is not technological, it is philosophical. Can we evolve faster in wisdom than we do in power? Our tools grow exponentially, our knowledge multiplies, our influence expands beyond Earth itself, but wisdom grows slowly, shaped by experience, humility, and restraint. If wisdom lags behind power, collapse becomes inevitable, but if wisdom leads, then power becomes a force for preservation rather than destruction. The discovery of life beyond Earth may accelerate this maturation. It forces us to confront the fragility of life, not as an abstract idea, but as a universal reality. It reminds us that biospheres are rare, delicate structures balanced against entropy. It shows us that survival across billions of years requires cooperation with nature, not conquest of it. Perhaps this is the true cosmic lesson, that life does not flourish through competition alone, but through cooperation. Within ecosystems, within civilizations, and perhaps, eventually, between worlds. In the distant future, humanity may encounter other intelligent beings. The forms they take, the ways they think, the values they hold, all remain unknown. But one truth will likely unite any advanced civilization: the recognition that survival depends on balance. Civilizations that fail to learn this truth may burn brightly, briefly, and vanish. Those that learn it may endure across cosmic time. If humanity hopes to become one of the enduring civilizations, then this moment, the discovery of life beyond Earth, may mark the beginning of that transformation, not because we found others, but because we found perspective. The realization that we are not alone dissolves the illusion of centrality. It invites humility. It encourages cooperation. It reminds us that our conflicts, our divisions, our rivalries are fleeting in comparison to the vast continuity of life. Under alien skies, life breathes without knowledge of us, and under our own sky, we now breathe with knowledge of them. Two worlds, separated by light years, connected by chemistry and time. This connection reshapes meaning. Our existence is no longer an isolated event. It is part of a cosmic process, a grand unfolding that began long before Earth formed and will continue long after our sun fades. Each civilization that emerges becomes a brief conscious flare in an otherwise silent universe. A moment when matter reflects upon itself. And in that reflection, the universe becomes aware. This is perhaps the deepest significance of life, not simply survival, but awareness. The capacity to know that existence exists. Through us, the universe observes itself. Through alien minds, it does the same. Every thinking being, wherever it arises, becomes a witness to cosmic reality. And in that witnessing, existence acquires meaning, not imposed from above, but emerging naturally from consciousness itself. When we gaze at the stars, we are not merely looking outward. We are participating in a dialogue billions of years in the making. Atoms forged in stellar furnaces now form eyes, brains, and instruments capable of understanding those same stars. The universe studies its own origins through the minds of its creations, and in that circularity lies profound beauty. One day, humanity may send probes beyond our solar system, tiny machines propelled by light, artificial explorers crossing the darkness between stars. They will carry our mathematics, our music, our languages, our stories, fragments of our civilization encoded in beams of light and pulses of energy. These signals will drift outward long after we are gone, crossing vast distances, reaching distant worlds, perhaps encountering other intelligences, perhaps not. But even in silence, those signals will serve a purpose. They will announce that once, on a small blue planet orbiting a modest yellow star, a species arose that wondered, that asked questions, that sought connection, that reached beyond itself. In that gesture, humanity becomes immortal, not through domination, not through conquest, but through curiosity and humility. Because true immortality is not lasting forever, it is contributing meaningfully to a story larger than oneself, the story of life in the universe. As we stand on the threshold of this realization, the future stretches before us like an uncharted sea, uncertain, dangerous, full of possibility. We do not know what discoveries await. We do not know what civilizations may rise or fall. We do not know how humanity's story will end. But for the first time, we know our story does not unfold alone. Somewhere beneath alien skies, beneath crimson suns and silent clouds, chemistry has assembled itself into living systems. Something breathes, something adapts, something evolves, perhaps something wonders. That knowledge transforms fear into awe, isolation into connection, silence into anticipation. The universe is no longer an empty stage. It is a living arena, a grand experiment unfolding across space and time, and humanity has become aware of its role within it. We are no longer just inhabitants of Earth. We are participants in a cosmic narrative, a narrative written in starlight and biology, in gravity and time, in atoms and awareness. This realization does not diminish us, it elevates us, because to understand our smallness is to appreciate our significance. We are fragile, we are temporary, but we are capable of wonder, and that wonder is powerful. It drives exploration, it fuels discovery, it inspires protection, it gives meaning. As long as humanity continues to ask questions, to seek understanding, to protect life, and to pursue wisdom, our presence in the universe will matter. Not because we are exceptional, but because we care. And perhaps that is the ultimate measure of intelligence. Not technological power, not expansion, not dominance, but care. Care for life, care for knowledge, care for the fragile balance that allows existence to flourish. In the end, the discovery of life beyond Earth does not answer all our questions. It multiplies them, and that is its greatest gift. Because questions propel progress. They drive curiosity. They ensure that exploration never ends. And as long as exploration continues, so too does hope. Hope that humanity will rise above its limitations. Hope that wisdom will guide power. Hope that life, wherever it arises, will be protected and cherished. Hope that one day, distant civilizations may look toward our faint star and see signs of life, just as we now see signs of theirs. And in that mutual recognition, across the vast ocean of space, two distant worlds may finally understand the same truth: that none of us are alone, that existence is shared, that life is universal, that awareness binds the cosmos together in a silent, eternal conversation. And so, as we continue to gaze into the depths of space, listening to the faint whispers of distant worlds, we carry with us a new understanding. The universe is not indifferent. It is alive with potential. Every star is a question. Every planet is an experiment. Every living world is an answer. And humanity, standing between ignorance and understanding, becomes the bridge between matter and meaning, between silence and awareness, between isolation and connection. This is our moment. This is our awakening. And the journey has only just begun.